Take care, Billy. Oh, hi, Teddy.
Oh, hi, Billy. Who was that just left?
That was Mathmaticus.
Mathematicus? I love that guy. What was he helping you with?
He was helping with type 1 and type 2 errors.
Errors? We don't need no stinking errors!
Exactly.
This looks like a job for Mathmaticus. Defender of truth, justice, and correct math problems everywhere.
In statistics, we're often testing hypotheses, and our hope is to reject the null.
Rejected.
But there is a chance that we could have been wrong.
Errors? We don't need no stinking errors!
If you reject the null and you're wrong, that's called a
Type 1 error.
or a false positive. Other times, we fail to reject the null,
Fail.
and in those cases, we might still be wrong.
Errors? We don't need no stinking errors!
In those chances, it's a
Type 2 error.
or a false negative. To help you keep straight, type 1 errors, false positives, and type 2 errors, false negatives, I have some examples for you. There's a lot of research out there on diet sodas and the effect on somebody's weight. On the surface, drinking diet soda sounds like a win if you can really put up with that artificial sweetener, as you can drink as much as you want without having any effects on the waistline. Or can you? In this situation, for the null hypothesis, mu is equal to 0. The alternative hypothesis is mu is less than 0, where mu is the amount of weight a person gains when drinking diet soda. Hey, Mr. Adams, I heard that drinking diet soda helps you lose weight. You want in on this? That's interesting, Billy. Well, let me do some research. Let me look at some statistical studies, and I'll let you know later. Okay, I'll talk to you later then.
Type 1 error.
Errors? We don't need no stinking errors!
According to a study from the American Beverage Association, the p-value is low. They rejected the null,
Rejected.
and drinking diet sodas may help you lose weight. I think I'll get in on this. Excellent.
Hey, this is my bunch.
I gained 5 pounds. Curse you, type 1 error.
Explaining the type 1 error in context. The studies show that drinking diet soda will help you lose weight, but the truth is, it does not help you lose weight.
The consequence of the type 1 error in this case is that Mr. Adams drank lots of diet soda, only to find it didn't help him lose any weight. Now let's rewind the situation and look back from a type 2 error perspective.
Type 2 error.
Errors? We don't need no stinking errors.
According to this Journal of Biology and Medicine study, the p-value was high, so they failed to reject the null.
Fail.
There is not sufficient evidence to suggest that drinking diet sodas will help you reduce weight. Maybe I should tell Billy. Nah. I lost 10 pounds! Curse you, type 2 error.
Type 2 error in context. The studies show that drinking diet soda does not help you lose weight, but the truth is, it does.
The type 2 error in this case is that Mr. Adams could have been drinking diet soda over and over and over again to help him lose weight, but he didn't because he didn't think it was effective.
Do not try and bend the spoon. That's impossible. Instead, only try to realize the truth.
What truth?
There is no spoon.
There is no spoon?
What I have in my hand right here is a spoon detector. Mr. Adams uses this device in his crazy household because there is one person, the spoon master, who knows whether or not there are any clean spoons ready for use at any meal. But that spoon master will not tell Mr. Adams if there is a spoon or not unless the meal has been fully prepared. So Mr. Adams uses his foolproof spoon detector to determine if a spoon is available before he cooks a meal. Things like soup or cereal that require the use of a spoon.
There is no spoon.
The null hypothesis is mu equal to 0, that there are no spoons available. The alternative hypothesis in this case is mu is greater than 0, where mu is the number of spoons clean enough to use.
Type 1 error.
Errors? We don't need no stinking errors.
Ha! The p-value is low. We reject the null hypothesis.
Rejected.
We have strong evidence that the spoon master has more than 0 spoons.
What are we having for dinner, Daddy?
We're having soup today, Teddy. Okay, spoon master, lay the spoon on us.
There is no spoon.
There is no spoon.
Curse you, type 1 errors.
Type 1 error in context. The studies showed that there were more than 0 clean spoons, but the truth is, there were no clean spoons.
The consequence of the type 1 error in this case is that there is soup there ready to eat, but there are no spoons to eat it with. That might make for a messy meal. Let's rewind the situation and go back to the beginning and take a look at the same case from a type 2 error perspective.
Type 2 error.
Errors? We don't need no stinking errors!
Aw man, the p-value is high. We failed to reject the null hypothesis.
Fail.
We do not have strong evidence that the spoon master has more than 0 spoons.
There is no spoon.
Hi, Daddy.
Hi, Daddy.
What's for dinner?
Peanut butter jelly sandwich.
Yes.
Okay, kids. Here's your peanut butter jelly sandwiches.
But I don't like peanut butter and jelly sandwiches.
But we don't have any spoons that are clean enough to make soup with. What? Ow! Ow! Ow!
Curse you, type 2 errors!
Type 2 error in context. The studies showed that we did not have more than 0 clean spoons. But the truth is, there are more than 0 clean spoons.
The type 2 error in this case is that Mr. Adams could have made soup and enjoyed his wonderful soup and been able to eat it with a spoon. Instead, he had to make something else to eat because he didn't think there were any spoons available. Now let's look at our last example. Home pregnancy test the urine to see if it contains the hormone HCG. In the case it finds it, it comes out and says you are pregnant. So our null hypothesis, which is nothing new to see here, would be there is no HCG, or P is equal to 0. The alternative hypothesis would be P is greater than 0, where P is the percent of HCG in the urine sample.
Type 1 error.
Errors? We don't need no stinking errors!
The P is low, we reject the null.
Rejected.
We have strong evidence that HCG exists. Hey honey, we're pregnant! Doctor, the home pregnancy test says that I'm pregnant, but I'm starting to have my doubts. Okay then, let me give you a pelvic exam. They're very accurate. Your pelvic exam just told me you're not pregnant. Sorry about that. Curse you, type 1 error!
Type 1 error in context. The study showed that the percent of HCG was more than 0, but the truth is the percent of HCG is not more than 0.
The consequence for a type 1 error in this case is that Mr. Adams got his hopes up, only to be dashed on the rocks. They also bought some prenatal items that will not be put to use anytime soon. Now let's rewind and take a look at the case again, but this time with a type 2 error.
Type 2 error.
Errors? We don't need no stinking errors!
Oh man, the P is high. We failed to reject the null.
fail.
We do not have proof that HCG exists. Hey honey, it's negative again. Doctor, the home pregnancy test says that I'm not pregnant. But I'm starting to have my doubts. Okay then, let me give you a pelvic exam. They're very accurate. Your pelvic exam tells you that you're pregnant. Sorry. Curse you, type 2 error.
Type 2 error in context. The study showed that the percent of HCG was not more than 0, but the truth is the percent of HCG was more than 0.
The consequence of a type 2 error in this case is that Mr. Adams didn't buy any prenatal care items that would have helped during the first few weeks of pregnancy. I hope this video has helped you to remember the difference between a type 1 error and a type 2 error, and that now you'll be able to eloquently explain the type 1 and type 2 errors in context for any kind of situation you're given.
Mathmaticus.
Mathmaticus out.
Mathmaticus.